All right, I believe it is 9 p.m., so let's get started. Welcome everyone to the Intro to Authentication Systems workshop. This workshop is going to teach you everything you need to know about authentication systems, and by the end of it, you'll hopefully be able to build your own one. So yeah, without further ado, let's jump right in. A little bit about myself. My name is Harshith. I go by pronouns he, him. I'm a grade 12 high school student with about a year of experience working at startups and learning about software development. I've been learning about authentication for about 4 months now. I'm excited to share what I know with you today. If you guys are looking to reach me after the workshop, if you have any questions that I didn't answer or you just thought of something to ask, my Discord tag is listed here. And if there's any other questions related to careers or things like that, I also have my portfolio link here as well if you guys want to reach me. So feel free to use those after the workshop. All right, so getting into the agenda, the workshop is split into 4 sections. We have the problem, the solution, the implementation, and the future of authentication. So the first 2 sections are very theory heavy, so we're going to try to get through them as fast as possible. And then the third section is the coding part, so that's the one that I'm waiting for and I'm excited for. And a lot of people are probably going to be excited for that as well. And then the last one is just kind of like a wrapping up section, and we'll talk about next steps for you guys and answer any questions you might have. All right, so just a pre-workshop checklist before we begin. Make sure you have the required tools. The main ones are Node.js, Npm, Git, and GitHub, and make sure you have Visual Studio Code. I highly recommend to have Visual Studio Code just because there's a extension called REST client within VS Code, and that's very, very useful for this workshop. It'll allow us to send HTTP requests very easily, so I would highly recommend it. If you really, really don't want to use Visual Studio Code, that's okay. You can use the Boomerang REST client Chrome extension or any other means of sending an HTTP request to the local host. So as long as you have that, that works. In terms of asking questions, feel free to ask a question on Slido at any point. The details for joining Slido are here, and they're also listed in the hop-in chat. So feel free to go on slido.com and then enter in this specific code, and you can ask any question. During the workshop, I'll probably be checking Slido a couple times, and then mostly during the end of the workshop, I'll answer any questions there. So yeah, feel free to ask. And it is 9:02 p.m., so I think we can probably get started at this point. So I'll start with the first section. This section basically aims to teach you guys why do we need authentication systems and what problem do they solve. There's really no point in creating an auth system without understanding what exactly the purpose of it is. So this section is going to teach you all about that. It's a pretty short section, so I'm actually going to give you the answers right away. There's 3 problems that auth systems aim to solve. So the first one is keeping track of authenticated state. So right here, we have an example of refreshing the page logs you out. So what that basically means is if you've ever been on a website like Facebook or any other popular website, you know that when you log in, you stay for a couple hours or maybe you browse for some time. And then once you close the tab and you come on the next day, you're still logged in. And the reason for that is because of something called authenticated state. So authenticated state keeps track of whether or not a user is logged in or isn't logged in. And that's basically the browser or the application's way of making sure that certain users are allowed into the application at all times and certain users are not. So without an authentication system, it's very difficult to keep track of authenticated state. And basically what that means is that whenever you refresh the page, that essentially logs you out of the application. So if you want your users to be kind of staying in the application until they click the logout button, an auth system is a great way of doing that. So we're going to discuss more about that later on. The second thing, probably the most important thing when it comes to authentication systems, is limiting access to APIs. So if you have an API that you deploy to the cloud, if you have private data on that API, which a lot of people will have, then one thing you want to make sure that you don't do is allow just anyone to make a request to that API. So what that means is if you went on Slack's API, for example, and you made a request to Slack, it won't actually just give you a request until you're logged in. So you're authenticated, basically. So that's basically exactly what authentication systems do. They limit the access to an API, and they make sure that only certain people can actually have access. And that's basically the whole purpose of authentication systems. One thing that I have noticed in the past is people using secret keys. So secret keys is just like a random list of characters or variables. I've seen people actually use those secret keys to secure API requests. Now, the issue with these secret keys is that they're not entirely secure. So what that means is that if you leak the key then you essentially leak your data. So that's where the auth system comes in. It kind of steps in front of the secret key and says, here's a much more concrete way of securing your APIs. So that's probably the biggest problem that auth systems solve. Now, last one, probably something that those of you who are interested in software engineering as a career probably going to be interested in, is that large companies require auth systems. So if you're ever working at a large company as a full stack developer or backend developer, it's probably paramount for you to understand how auth systems work and how things like Jwt and Session Auth work, things that we're going to talk about in this workshop. So that's kind of like the big thing when you're starting in your career as a software developer. A lot of companies are going to require you to understand how auth systems work. In addition to that, if you ever build an application that scales to the enterprise level, a lot of these big companies will require evidence of a strong auth system. So if you build a startup and you scale it to a large level, then you're going to be required to incorporate things such as two-factor authentication and good authentication systems. And the reason for that is because no big company wants to let their employees be hacked or go use an application that is basically unsecure. So these are the three problems that auth systems aim to solve. And just to summarize, what exactly is the problem here? Well, the problem is that there's a lack of a streamlined way to allow certain people in and keep others out. That is basically the issue that auth systems aim to solve, and what we're going to try to solve today as well. And this brings us to the second theory section. We're moving pretty fast, but that's good because we're going to be getting to the coding part very, very soon. So in terms of solution, what we aim to do here is understand, now that we understand the problems, we're going to brainstorm some possible solutions. And fair warning, authentication systems are a little bit complicated. So because of that, we're going to take a look at things from a scenario. Let me get my laser pointer out real quick. All right, so we have a scenario before us, and the scenario basically says that you have a top secret vault. Now, this top secret vault has some cool secret stuff in it. You can imagine whatever that is. And there's the head of security who controls the vault. You can imagine yourself as a head of security if you like. Now, the issue is that we have about 500 people who are owners, bankers, and security people who need access to this vault. And we have another group of people, robbers, and some more robbers who shouldn't have access for obvious reasons because they want to steal whatever's in the vault. So the question is, how do you give these 500 people access? How do you make some sort of verification system so that these 500 people have access to the vault, but these robbers, this group of robbers, don't have access? Now, this might seem like a simple question, but the key here is that this is all before the age of computers. And if you might be asking, why is this before the age of computers? It's basically just because it makes the scenario a very convenient one. So it's before the age of computers because it basically makes the auth system or the authentication system you're going to use here a lot harder. You can't just use a spreadsheet or like one of those IDs with a barcode and just scan those barcodes, give them to those 500 people and allow them in. That doesn't exactly work because we have no computers, we have no databases, we don't have much electronics here. All we really have is a pen, a paper, and that's basically it, and the ability to distribute whatever we want to these 500 people. So the question is, how do we do that? Well, we're going to brainstorm some solutions. The first one says this. We have a visitor, and this is an unknown visitor. We have no clue whether they're an actual visitor, like a person who should have access, or a robber who shouldn't have access. Now, the visitor is going to come in, and they're going to show a unique identification number. The identification number can be anything. It's just going to be like a list of characters. It can be a list of numbers. It doesn't have to be a number. It can be basically anything, right? It's just a random list of characters and numbers. And we go ahead and we take that character or that character list, take that ID, and we have a big list, like a stack of papers. So this stack of papers is going to be like 500 papers long because we have 500 people within our allowed people list. And it's going to contain all the IDs that we've ever distributed. So in this scenario, we're basically assuming that we're going to take a stack of IDs, 500 IDs, and distribute it to these 500 people. So that's kind of what we're assuming here. And when someone comes in, they show us their specific ID. All we have to do is go check into that original stack of records. If it exists in that records and in that list of records, then they're going to be given access. If it doesn't exist there, then they're going to get thrown out. It's a pretty simple idea, and we're going to be analyzing the idea a little bit. So if we analyze it, there's some benefits and there's also some problems. So the main benefits are that unique IDs are harder to crack, right? So remember that here, every single ID is unique. So if every ID is unique and there's no shared pattern or key between them, then it's harder for a robber to go ahead and just make a new ID that they can use. One, because it's not going to be in the list of records, and two, because there's no pattern between these IDs. So unique IDs are harder to crack, and it's harder to just like make up a fraud ID. So they're mostly random, right? And the second thing is that if an ID was leaked, say one of these visitors decided for some random reason to leak an ID to a robber. Say the robber comes in the next day, but the visitor says, "Oh, hey, I accidentally leaked an ID to the robber. I don't want my the vault access to be terminated. Can you do something about it?" We would go ahead and we would just say, "Hey, let's delete that ID from this list of records." So that robber who has that specific ID now can no longer get access because it doesn't exist within this list of records. So it's a very, very easy way to delete that ID from the records and basically revoke access if an ID was leaked for some random reason. So those are the benefits when it comes to solution 2. Now, if we look at the problems, you might have already guessed this, but it's basically inefficiency. That's the main problem. We have 500 people, and that is a lot of IDs to remember or even write down. So 500 records, 500 pieces of paper within an actual box. Imagine trying to take those 500 pieces of paper and look through every single one of them whenever a visitor comes in. Let's estimate that 20 visitors come in every single day. That means that you're going to have to check 500 IDs 20 different times. And that is a long process, and it's a time-taking process, and it's a very inefficient process. So that right there is a problem, right? You can't be bothered to search through them all. It's too many IDs to search through, and it's honestly just way too inefficient. And if you connect it back to software, it's a lot of storage. 500 people, an ID for every single person, that's a lot of storage. So because of that, we created solution 2 as well. Now, solution 2 is a little bit more complex, but it solves some of the problems that solution 1 brings up, but it also brings some of its own problems along. So what it says, we have visitor again, an unnamed visitor, and they show an ID just like last time, but the ID is a little bit different. It's created from a secret pattern. So what that means is that every single ID, all the 500 IDs that we've distributed out, we don't even have a list of records for them. We just distributed it, we just like give them out, and every single ID has a specific pattern that it was created from. Like for example, one lowercase letter, one uppercase letter, a number, and a special character. That's just like a very small example. It'd probably be like 14 or 20 times longer than that. But essentially, we have an ID that's created from a pattern or a specific key. We don't need to worry too much about the algorithm that was used to create such a pattern. All we really need to worry about is that this ID was created from a specific pattern or from an ID. And when a user comes in or a visitor comes in, all we need to do is check that pattern and check the key. So we just check whether or not the key matches our pattern or whether or not it actually came from the pattern or the key that we used to create it. And if it does, if the pattern is valid, then they get access. If the pattern is invalid, they don't get access. So to give you an example, because I know this is a little bit difficult to understand, think of the user coming in with the pattern A, capital B, 1, and hashtag. And our pattern basically just says the exact same thing. It says lowercase letter, uppercase letter, number, and special character. Because it meets our specific pattern, we let them in. The pattern is going to be a lot more complicated, of course, and it might not even just be a pattern. It could be like an algorithm that we apply. But nonetheless, it's a pattern. It's an algorithm that we're applying to specific a common character, a common pattern between all of the users. And because of that, you might notice that we don't have any of these records anymore. So that's actually part of the analyzing. But yeah, the benefits with S2 is that we remove our solution 2. We remove a step that makes the entire process completely inefficient. So in solution 1, we have this big list of records, 500 records. And we have to create those records. We have to search through those records. And that's like a big pain. In solution 2, it doesn't exist anymore. We don't even need to check the records. Every single time someone comes in, it's like a 20-second check with their pattern, and we let them in. It's very, very efficient in this manner. Obviously, because there's less storage required, there's less work. You just memorize the pattern, you check the pattern. Very, very simple. Now, there are some problems, and as I said, it does bring up some of the problems of its own. And the first problem is that if someone got the pattern, they would have unlimited access. Why is that the case? Well, remember that the pattern is the same across 500 people. So if someone got the pattern, this person leaks out the pattern to a random robber. The robber comes in, and either they show that ID or they create a new ID from that pattern. And suddenly we can't actually verify or revoke the access that easily. If the robber has that pattern, they can create infinite IDs from that pattern until we change the pattern for all 500 people, which I don't think anyone wants to change the pattern for 500 people. So that obviously is a problem there. And you might be thinking, well, what are the chances they're going to get the pattern? Even if they get the ID, It's like a pattern has been applied. How are they going to crack the pattern? Even if the ID is difficult to crack, these IDs are breakable, right? So Murphy's law is that anything that can happen will happen. And in this case, if the pattern is breakable with enough effort, it eventually will be breaked. So that means that these IDs are breakable. And that is the basic problem with solution 2. Although it's inefficient, it's insecure due to the risk of pattern leak. So now comes the question, which solution is better? Is it solution 1, which is inefficient due to too much storage, or solution 2, which is insecure? It's obviously efficient, but it's insecure due to the risk of pattern leak, and someone can get access to the vaults if they have the pattern. So I'll give you guys a second to think about this. If you like, put it in the chat or whatever. Just think for a second about which solution might be better. All right, I'm going to assume that you guys have your solution in mind. The answer is, maybe even surprisingly, solution 2. You might be thinking, like, why exactly is solution 2 better than solution 1? It's basically because, like, in software, we're talking about software technically. In this specific scenario, you might be right. Solution 1 might be better. But if you could fix the flaws, the security flaws that come with solution 2, you'd find that it'd be 10 times better than solution 1. It saves a lot more time. So with solution 2 in software, it's 10 times better because it can easily, we can easily fix the flaws that come with solution 2. Now, solution 1 is used. It's actually called Session Authentication. You might have heard of it before. It uses these things called cookies, and it actually operates in the same manner that we just talked about. Every user has their own little row, own little ID that we have to store in the database, and obviously that's very, very inefficient. Jwt does present, Jwt being session solution 2, we're going to call it Jwt from now on. It stands for Jwt Tokens. We'll talk everything about Jwt, don't worry about that. But it is better just because we can fix the fact that it has these insecurities. So basically, we have a slide for this. Why is Jwt better than Session Auth? Well, it's basically because it requires zero storage. It's a lot more scalable. In software, performance and scalability is king, right? So when you get to like 1 million users within your application, Session Auth requires you to store 1 million rows of data. That right there is a problem because not only is it difficult to loop through those 1 million rows of data and try to check for the specific user that is requesting access to your application, it's also costly because 1 million rows, Amazon isn't going to give you 1 million rows for cheap. That's going to be a lot of money. I say Amazon because AWS and like big cloud platforms, they're going to charge you a lot for 1 million rows of user data, of user IDs. Whereas with Jwt, that doesn't exist. You literally just scrape off a bunch of money off your bill, and you can save a lot of performance. And like I said, Jwt's security flaws can be fixed. And the reason they can be fixed is because software today is powerful. And second of all, Jwt, the flaws don't actually originate from the system itself, where session authentication, it originates from the system. If you think about it, session auth is basically like, we have that records, we have those lists of records. That's what creates this entire problem. It's the system itself, that's how the system is made, that's creating this inefficiency. But Jwt's flaws just originate from the token. The stronger you make the token, the more impenetrable you make the actual storage device for the token, wherever you're storing the token. If you can make sure that no hackers can get access to it, then suddenly the security flaws can actually be fixed or at least mitigated. So because of that, because it has some advantages over session cookies, we're going to take a deeper look into it. So we're reaching the midpoint for the theory part, so just hang in a little bit longer and we'll soon be finished. So what are Jwts? That's the basic topic of this slide here. And this is what a Jwt looks like. It can look a little bit complicated. It's basically just a bunch of just like jumbled up characters and numbers, as you can see. And each specific section of the Jwt has a purpose. So it's split up into 3 sections: the blue part, the green part, and the red part. So the colors correspond to each little square here. So the header, or the blue part, is basically a storage mechanism for the algorithm that the Jwt is made with. I told you in solution 2 that our tokens or our specific IDs are going to be made with a specific algorithm or a pattern or things like that. The algorithm is basically that representation of a pattern. And the type is basically just says, this is the JSON web token. We don't really need to worry too much about the header. It just tells us a little bit about what the algorithm that we're using in this case. The second part is the payload, and the payload is probably the part that's going to be the most interesting for us. So the payload allows us to store any type of data. We can store strings, we can store arrays, we can store objects, we can store numbers. We can basically store whatever type of data that exists that can be put into the payload. And that payload, that data is going to be encoded into this green part over here. And when we crack open a JWT, because you can actually open JWTs once you create them, we're going to get this resulting payload once we do that. So it's a very, very efficient way, a very, very good way to store data within an actual JWT. Similar to how Session Auth does it, it allows you to store data within the payload. So it's really good for that. Lastly, we have the signature. And the signature actually allows us to confirm the validity of a JWT. So the signature right here is actually like responsible for fixing some of the flaws within solution 2. It allows us to go ahead and say, okay, so we have this specific token. Whenever you receive the token, for example, like the client sends it to the server and it says, oh, hey, let me into the application. I'm a verified person. The signature is what we're going to check. We check the signature and we say, okay, is this person, we check two things actually. We say, is this person saying whoever they say they are they actually that person? Is this token coming from where it says it's coming from? And the second thing is, has it been tampered with at all? Has this token been changed in any way? Has anything about it been like opened or changed? That's what we're going to check here. And that's essentially the purpose of the signature. It adds that security element to it. The last thing I want to say before we move on is that the payload also stores an expiry date. So Jwt tokens can expire. They have an expiry date, like it can be like forever. It can last up to like 100 years if you wanted to. But ultimately, it expires at a certain date. And at that date, this payload contains a specific date at which the JWT is going to expire. So that's exactly how the server is going to basically, or whatever application you're using, is going to tell whether or not the JWT is still valid or expired. Now, there's two types of JWT tokens. There's access tokens and refresh tokens. So access tokens are short-lived tokens that expire after 10 to 15 minutes to ensure security. So I told you that JWT tokens could expire. This is the purpose of security in terms of JWT. The access token has a specific purpose, and its sole purpose is literally to tell any server, when we're going from the client to the server, it tells the server at any point that, hey, I'm an authenticated person, give me access to your private data. That is literally all the access token does. It has no other purpose other than telling the server that I am an authenticated individual. Here's my, you're basically saying, like when you go to the airport and you show your passport and you're saying like, okay, I want to go to this country. It's basically exactly that. You tell the specific server, you say, okay, I'm this specific client, give me access to your private data. And that's all it says. Now, the good thing about access tokens is they're our main communication between the client and the server, our main source of authentication, of course. So if a hacker actually gets access to the access token, they'll only have access for a short period of time. It's a lot of access there. But essentially, it expires in 10 to 15 minutes, which means that if anyone ever gets access to it, they only have access for like exactly 10 to 15 minutes. So it's good in that sense. Now, refresh tokens are kind of like, I'm trying to think about how to explain it. If you ever like renew your driver's license, or if you ever renew your passport, this is kind of what refresh tokens do. They basically are used to renew an access token, because oftentimes you're not going to be spending just 10 to 15 minutes on an application. So when the access token expires, you need to get a new access token in order to make requests and get some private data. And refresh tokens allow you to obtain a new access token. These are the tokens where you do not want to leak these, because they are long-lived. They live until 30 days, and sometimes they're permanent until the user logs out, which is dangerous, and I wouldn't advise that, but they are long-lived tokens. If hackers get access to refresh tokens, they can just keep generating infinite access tokens, just like solution 2. So these are the ones where we really need to be careful in terms of securing them whenever we're using refresh tokens. So these are the two types of tokens, and it might be hard to wrap your head around how exactly the system works. So I've created this nice little diagram. So we're going to go through it like piece by piece. We have this client app right here, and it's app.com, whatever your app is, right? So it's going to be deployed to a server or deployed to the client, whatever. It's just going to be deployed, and we have this client application. When the user comes on the client application and they want to log in to the app, what they do is they go ahead and they enter in their username, they enter in the password, and the client goes and sends a post request to the auth router. What is an auth router? It's just like a collection of authentication routes. That's all that it is. So it sends a post request to the auth router, and the auth router sends a refresh token, a cookie in the form of the cookie, and an access token back. What exactly does that mean? Well, when it receives the request, it's going to have the username and password within the request. The auth router is going to check that, and if it matches up with what it sees in the database, if that user exists, it'll send back a refresh token in the form of what we call a cookie. A cookie is basically like a a little thing that attaches itself to every request, right? So all it does is it goes on every request that we want it to. It's an efficient way to transfer or essentially keep data attached to a request. That's literally all it does. It's kind of like a little thing that attaches itself to something else, right? So USB, if you will, I don't know. It's just something that attaches itself to every request. And it goes back and forth between the client and the server. It always stays with the client, and it just keeps going back and forth. The refresh token is stored in the cookie, and the access token is just set back in the body of the request. So now that the client is authenticated, it's basically logged in at this point. It goes and it makes a request with the access token in the header. So that hits the middleware, and the middleware is going to go check that access token. It's going to say, is this access token valid? What is middleware? Middleware is basically just like a function that runs whenever a request is made to a server. So you can set up middleware so that whenever a request is made to a specific route, the middleware function runs. So in this case, we're making a request to the resource API. So the middleware is going to run. It's going to say, is this access token valid? If it is valid, then it forwards that request to the resource router. If it's not valid, it's going to say, like, get out of here, you're not valid anymore. So you can get lost. The middleware basically checks the access token. Once it forwards the request, they have the resource router. This is a lot of fancy names here. The resource router is literally just the route that stores our private data. It goes to the database, it gets some data, and it returns it. That's literally all it does. It doesn't care about security, doesn't care about authentication. It says, I'll let the middleware handle that. If I'm getting a request, that means the user is authenticated. So I'm going to go return the user information. And this is how the Jwt system works. Once we get the user information, we do some stuff on the client, we make another request, and we go on and so forth until the access token expires. And that's where refresh tokens comes in. This should say refresh, not refresh, but refresh tokens are still attached to every request, so they're still there. And now, once the access token once it expires, we make a request to the auth router once more, and we say, give me a new access token because my refresh token has, basically give me a new access token. My access token is now expired. So we post it to the refresh route or whatever other route, and the auth router is going to do the exact same thing as it did before. It's going to get the refresh token. It's going to check its validity. If it's valid, it'll return a new access token. And this entire cycle goes on over and over until the user logs out, and then they log in again, and just continues on and on. And that is basically how the Jwt system works. Now, you may have some questions about the insecurities that we brought up in solution 2. So this is how we can fix those insecurities and secure Jwts. The signature does that. The fact that we have access tokens and refresh tokens, those also contribute to security. But these 4 things can also really make sure that you have secure Jwts. So the first thing is that we store the refresh token in a specific type of cookie. It's called an HTTP only cookie, a same site strict cookie, right? So that's a mouthful. What that means, we're going to take it apart like piece by piece. So what that essentially means is that we're storing the refresh token in a cookie, and within the cookie, what we have is HTTP only and same site strict. So what does HTTP only mean? All it means is like a fancy way to say that no other service, no other place other than the server can access or modify the cookies. So why do we do that? Well, we don't want anyone getting access to the refresh token. The server is basically like the safest place on the planet for any application. Why? Because it's hard for someone to get access to the server because it's literally running on a computer in an encrypted environment. It's very difficult to get access to the server. But the access tokens or the client side, that's very easy for someone to get access to. So when the refresh token gets sent back to the client in the form of a cookie, we don't want someone to just hack through the client and get access to it. Because of that, we're setting HTTP only, and that makes it so that only the server can access these cookies and only the server can modify them. And that makes sure that any hacker who tries to get these cookies and change them, that never works, and because they just can't access it anymore. The second part is same site strict. So same site is literally a property that says this cookie or this specific resource is not going to be sent to any other domain other than the domain that I'm residing on. So if our server is running on app.com, right? So it's running on app.com, it's not going to be sending the cookies to any other domain, any other website other than the app.com domain, right? So any path within the app.com domain is going to be sending the cookies there. Why do we want that? Well, that's basically just because we don't want these cookies to go on other sites, insecure sites, whatever other sites that exist out there. Hackers can much more easily get access to our cookies on random sites that we continue to send our cookies to, our refresh token cookie, compared to just keeping it in our own domain. So same site strict says keep the cookie in our own domain and don't send it to any other sites. Fun fact, Facebook actually uses same site lax cookies or same site none cookies. That probably allows them to send cookies to other sites because we all know, Facebook tracks you across the internet. So that's one way that they accomplish that by not setting it to same site strict. The second one, and the rest of these are a lot easier than the first one, but the second one just says store the access token in JavaScript memory. So the client side is going to receive the access token, and what it's going to do is it's going to store it inside the memory of JavaScript. And what JavaScript memory is literally just a variable. It's going to store it within a variable, and the reason why we want to store it there is because that's the most difficult place for a hacker to access. We don't want to store it in places like the local storage. We don't want to store it in places like session storage or other places of storage within the browser, because those are generally insecure. Local storage is a relatively insecure place. If you can perform what's called an XSS attack, you can get access to the local storage. We don't want anyone doing that. It's difficult to perform an XSS attack and get access to the access token that's stored inside a variable within JavaScript memory. And whenever the user refreshes the page or closes the tab, it's going to literally refresh, because that's just how JavaScript memory works. So that makes it very difficult for hackers to get access to it. The third thing is set the access token to expire in 15 minutes or less. That's very self-explanatory. It literally just says, just set the token to expire as soon as possible, so that if any hacker gets access to it, they only have a limited period, a limited amount of time until they can no longer send requests. And the fourth part is don't store any sensitive information within a JWT. So if you remember when we talked about JWTs and how you can store payloads within them, we talked about how you can store basically any type of data. Whatever you want to do, don't store any sensitive information within a JWT, because it's to crack a JWT, it's as easy as going on jwt.io, pasting the JWT in the actual text box there, and seeing the output. It's very, very simple and easy to crack a JWT. So don't store any sensitive information in there. That's not the purpose of it. So don't store any sensitive information like passwords, credit cards, none of that stuff within a JWT. All right, so we finally made it to the coding section. It's time to implement and code our token-based authentication system. So before we start, I'm just going to head over to the Slido and see if there's any questions here. All right, cool. There's 4 questions, so I'm going to try to answer these right away. So let's do the first question here. And the first question says, doesn't this setup still require as many rows as users in the database since you need to store login info? Okay, so basically what this person is asking is within the refresh token solution or the JWT solution, doesn't this setup still require users or to store your login info within a database? And the answer is no, it doesn't. So the reason why it doesn't require to store any information in the database is because we don't actually care whether or not we actually have record of that JWT. All we care about is whether or not that JWT was created with the key that we have. You're going to see this in the actual development more. But basically, if I go back to the slideshow here, let me just present that again. Anytime now. All right. So if you look at this specific diagram here, as you can see, we're not actually storing the JWT that we're giving back to the client at any point. All we're doing is we're returning that back to the client. We don't have a database where we're storing it. We're not doing any of that stuff. And the reason for that is because we don't care about whether or not we're that actually exists in our record. All we care about is, was the JWT made in our server, and was it made with the specific token or the specific secret that we're going to provide the JWT? And if it was, then we're good to go. We don't care about whether or not it's stored in a database. The issue with session authentication, to answer your question, is that session authentication requires you to store those specific tokens within a database. Otherwise, you have no other way of identifying whether or not that ID or that token came from the server, like the server that you're on. But JWT provides a method of doing that, which is something that we're going to see a little bit later. So the answer is no, doesn't actually require that, whereas session authentication does. Are there any other projects that you've made with JWT? Yeah, I have made a couple projects with JWT, mostly just full stack applications. It's pretty simple and pretty straightforward once you start using the actual authentication system. The point of today's workshop is that when we're actually storing the information, or when we're building the actual application, you should be able to take that code and apply it to any other project very quickly, very easily. So it's kind of like a plug-in and play setup. Does the use of JWTs only apply for situations like using an API to access data? Yeah, so that's somewhat basically what it's used for. So ultimately, all of software. So let me just explain the question. The question says that do JWTs only apply for REST APIs or just APIs in general in order to access data? Yes. And the reason for that is just because all of software runs on APIs, basically. You have to have some way of communicating with the database, communicating with the server to get access to user data like emails, passwords, credit card information, whatever stuff. That's where APIs come into play. And the point of JWT, the point of authentication systems, is to secure those APIs. So ultimately, they are used for situations like APIs mostly. You can also use it to, like I said, check authenticated state, whether or not a user is logged in. That's one other way to do it as well. So I hope that answers that question. What does JWT stand for? It stands for JSON Web Tokens. Web tokens just means that it's a token that's sent across the web, and JSON is a specific notation standard within JavaScript. You mentioned not to store anything sensitive within JWTs. If we wanted to send the user back their password, would we hash it or how would you do it? Okay, so basically this question is saying if you wanted to send back the user the password is obviously a secure information. It's like private user information, so we don't want to store any of that in the JWT. How would we hash it or how would you do it? So yeah, so in terms of passwords, there's actually something called hashing and salting, which you mentioned. Hashing and salting is very useful to store passwords within the database and also to make sure that it's encrypted whenever we're sending it across the server. You mentioned not how would you hash? Yeah, so I would honestly not recommend you send the password back to the user. If there's a specific reason that you're sending it back, then hash it and do it. But ultimately, I can't really think of any reason right now as to why you would go ahead and take that specific password and send it back to the user, because it's like a very easy way for a hacker to get access to the user account, is my opinion there. We're going to start coding in 2 seconds for whoever asked that. The other questions I'm going to answer at the end of the workshop, and I think the development part is probably going to answer a lot of those questions as well. So without further ado, let's get started with the development. Just give me a second here. All right, so this is how our development is going to work. We're going to start by cloning and setting up our project. Then we're going to go ahead and commence the server-side JWT implementation. And afterwards, we're going to test our auth system with some API requests. And I think once we start coding, a lot of people's answers or questions are going to be answered very easily anyway. So to start, you guys can just head over to github.com/search. I believe we are on time, so that's good. So we're just going to search for the starter repository here. And all you need to do is just say htn-auth-systems and search for that. And my internet is okay. Yeah, so it's the first and probably the only repository that comes up. So just click on that one. All right, so it's this repository right here. And once you've made it here, all we need to do is scroll to the bottom and just copy this code here. We're going to clone it. We're going to do just copy this specific code or this command line. Oops, that was not a good thing to click. But yeah, so we're going to go ahead and paste that down here. And I'm going to run that, and that'll clone into the HTN auth systems repository. So then I'm going to go ahead and cd into the repository. And I'm going to quickly run npm install. That'll probably take a second because I'm screen sharing and that makes my internet slow. It depends on what internet connection you're on. If you're on a slower one, it might take a longer amount of time, but just don't do anything, it'll finish off on its own. All right, cool, that was fast actually. So now that it's installed, what we want to do is open it up into Visual Studio Code. So I'm going to write code dot, and that'll open up in VS Code. If you don't have those terminal bindings, that should have opened. Oh, there you go. If you don't have those terminal bindings, you can just open up VS Code the old-fashioned way and just click Open Folder, and wherever you clone the project, you can just open it up there. All right, cool. So we have the repository set up here, or the folders and all the files. So right before we start coding, what I'm going to do is I'm going to do a quick test run, and I'm going to say npm run server. So don't do npm start because that's going to start it in production mode. I'm going to do npm run server, and in a second. All right, so that'll start the next.js, which is the entry point to our server, and we're just looking for listening on port 5000. All right, cool. So I see listening on port 5000. If you see that, then you're good to go. So I'm just going to quickly explain how this setup works. So we have index.js, and index.js is the entry point to our entire application. So basically how that works is we have initialized Express here, and we're setting up some routers. We have our app listening on a specific port. So that's how index.js works. It's the entry point to our server. The other folder that you want to be aware of is the tests folder. And this is the extension that we're going to use. This is the file that we can use to send HTTP requests. It's very, very simple and very easy to use. So we're going to be using this for that. And then we also have the server folder. This is probably the most important one. It has our routers. If you used Express before, you know that routers are basically just collections of different Express routes. So that's the auth router that right there. We're going to write out all of our auth routes. Then we have the cards specific router. The cards route has already been written out since it just interacts with like a database file. So we don't really worry too much about that. And then we have our middleware file, which we need to write out as well. You might notice there's to-dos, to-do comments on every single file. That's just to help you kind of figure out what to do and yeah, just to keep us on track. The other thing that you might notice is the database folder. The database folder just has one file, and that's the database.js. This is obviously not a proper database. And the reason for that is because we don't necessarily need to have an entire like SQL database or something. It's not a database workshop, so we want to have something that's very, very easy to interact with. This is obviously static, but our point is to learn about authentication, not databases. And we have a config folder, just stores in environment variables, which are kind of like global, like JavaScript variables, just variables that are available to the entire environment. So after that, what I'm going to ask that everyone does is go over to the extension tab and just search for a specific extension. We're going to search for REST client. And it's the first extension you see here. Try to install this extension. I already have it installed. It's very, very useful to send HTTP requests. A lot of you might already have it. And the second one is called Prettier. And Prettier is a formatting extension. It's the first one again, and it's very, very popular. So it just helps us format our code. You don't have to use this, but I already have the config file set up, so I'm going to use it. And now that we have everything set up there, I'm going to do a quick test run on our server. So I'm going to go to the REST file. And what I'm going to do is I'm going to say get HTTP localhost 5000. What we want is the health route. So I'm going to do that. And what we're going to do is send that request by clicking the send request button here. And we get a response. It says OK. So if it says 200 OK at the top and OK here, then you're good to go. Your server is running perfectly well. All right, so now that we have that initial route set up, I'm going to delete that because we don't need it anymore. We're going to start off with our auth file. So I'm going to start off by importing some stuff. So let's do const express require express. And I'll import Jwt as well, which is the helper module that we're going to use to build our Jwt token. So it'll be JSON web token that you're importing. And the last thing is we're going to import the database. So I'm going to say get type require and database, and then the database file. And what I'm going to do is I'm going to destructure out a specific part of the database file. I'll tell you why I'm doing that in a moment. I'm going to destructure out the user's object or the user's array within the database file. And I'm going to instantiate an Express router. I'm assuming that you guys know how to work with Express. So router is just kind of like a collection of routes if you've never used one before, but yeah. I'm going to export the router here. And I'm going to go to the index.js, and I'm going to require the router because we need to import it. I'll say auth router, require server, and we'll say routers, and then auth. And we'll use that auth routers right here. We'll say app.use, provided a prefix, we'll say /auth, and then we'll say auth router right there. All right. So now that's basically all the boilerplate we need for the auth router there. And what we now want to do is write our initial login route. So let's go back to let me just rearrange my terminal and stuff. So let's go back to the slides. We're going to use this a fair amount. Well, everything's really slow. All right, so we have our Jwt system here. I'm going to present that again. And all right, so what we have is the auth router, and we want to basically set up our initial login route. So within the login route, there's two things we're going to do. We're going to check to make sure that the username and password is valid. And if it is, we'll send back the refresh token in a cookie and the Axios token in the body of the request. Pretty simple. So let's get started. We'll say router.post. So it's going to be post request. Always make sure login and sign-up requests or posts because post is secure, get is not so secure. And the specific path that I'm going to say is going to be /session. So don't get this confused with session auth. I'll tell you in a second why I'm using /session. So post basically just stands for create a new, right? So you're basically creating something new. And in this case, if I use /login, it would kind of sound weird. Like it's not a good practice to use verbs in your API routes. Instead, try to use nouns, right? So in this case, we're saying create a new session. A session is just like any period of activity that the user has in a website. So if you log on Facebook, you spend some time there, and then you log out, that right there would be a session from the time that you started and the time until you logged out. So we're just creating a new session for our user here. And the first thing we want to do is check for the username and password, make sure that exists. So I'm going to open up the database file. And as you can see, we have a users object, users array, and a cards array. So the users array has little elements of basically an object of a specific user. So we want to go ahead and check these specific usernames. There's half the north and half the south. So we want to make sure that whatever username and password our request has been given, we're going to check to make sure that that exists somewhere within this specific array. So I'll go ahead and I'll say const matching user, and that's going to be the user that matches the username and password. And I'll say users.filter. So we're using an array method, and I'll pass in a specific user here, and I'll say username, the first thing, equals request.body.username. And we want another condition to check for the password. We're going to say user.password equals rec.body.password. And Prettier is going to complain about that. And then now we have our matching user. So what this gives us is it filters through the array and it says which specific row within the array, which specific object matches the username and the password that has been given to me in the request. And this is going to be an array that's given to us. So if there's no elements within that array, that basically just means that there's no users that match the username and password. If there's no users that match username and password, this user is basically invalid. This request is invalid. So we're going to say if matching user dot length equals 0, then return res.status. And I'm going to say a status of 401. That basically means unauthorized. I'm going to send back an object in the response. And the format that we're going to use for our entire project is going to say payload. And we'll say invalid username or password. And we're going to say success. So payload is the string or the data that resulted from the request. And success is a Boolean about whether or not the success of the request succeeded. So I'll say that. And that from now on, our user is basically authenticated, right? So in this case, it will just end the function by returning the specific res.status. It'll return the response, and it'll close the function if the matching user.length is 0. Now, if it's not, now we've got to create the access token and the refresh token. So let's start off with the access token. So I'm going to say const access token equals jwt.sign. jwt.sign creates a token, essentially. Now, this takes basically 3 parameters. The first one is a payload. I told you we can include some data within the actual JSON web token. So now we can specify what data to include. So I'm going to say const token payload. It's going to be an object. And what we're going to do is specify the user ID. I'll say rec.body. Or sorry, we're not going to do that. We'll say matching user, the first index, because we're going to get, this is still an array. And we're going to say user ID. And then we're going to say username is matching user again, first index, and username. And that'll give us our token payload. The question about whether or not we want to store the password here, we obviously don't, because we'll see in a quick second that the JWT is breakable. So don't store the password within the token payload, because someone can get access to it when they break open the JWT. Quick time check, and I think we're on schedule. So we'll pass in token payload here. And the second thing now is a secret or private key. So this secret or private key basically eliminates the need to store the tokens within a database, because all we do is for any incoming token, this JWT module is going to check for that specific key to be included within that token. It's going to be using some algorithms and stuff. We don't really need to worry about that, but it's going to check for that specific private key to be created alongside that specific token. So the token is going to be created from that key. Now we need to basically specify a random key. And what we're going to do is go over to our terminal. I'm going to open up a node shell, and we're going to use the crypto module. So I'm going to call crypto. .random bytes. I'll explain in a second what this does. And I'll pass in 64, and I'll say .toString, and I'll say hex. So this right here basically calls a crypto module, which is a cryptography module built in Node.js, and it says, give me some random bytes. Give me a length of 64, and I want, not like 64 exactly, but basically 64 bits. And it says, give me that specific string or that specific random bytes that you've created and transform that into a hexadecimal, and that's what that says. So if you run it, it'll give you a big string. I'm going to copy the interior. I'm going to head over to my config folder in the environment variable file and paste that as the Axios Token secret. We'll do that one more time. And we have a new one. So I'm going to paste that again in the refresh token secret. And that's all we'll need to interact with the end file from now on. So now we're going to pass in that specific private key. So I'll say process.env. That's how we interact with environment variables. And I'll say Axios Token secret. And the last thing we get to do is pass in some options. So options is where we're going to pass in the expiry dates or the expires in for these specific tokens. I told you that Axios tokens expire, and the amount of time that we have until it expires, we're going to write here. So I'm going to say Axios expires in, and this is going to be a string. And basically, we said that we want it to expire in 10 to 15 minutes. Most of the software operates in milliseconds. This can operate in some other stuff as well, but I'm just going to use milliseconds because that's standard. So that's 900,000 milliseconds is the Axios expires in. And we're going to do the refresh as well. Refresh is going to expire. I'm going to say that it expires in 60 days because I think that's relatively okay. And that's 5184 followed by 6 zeros. 1, 2, 3, 4, 5, 6. So that is the milliseconds for 60 days, I believe. And we're going to pass in the Axios expires in. If you're wondering why it's in capitals, all constants within JS is generally good practice to keep them in capitals. And now we're going to do the same for the refresh token. And I'm not going to type that out. I'm just going to shamelessly copy and put it there. And I'll switch the Axios to refresh. And I'll switch Axios expires in to refresh expires in. And there you go. We've created our first 2 tokens. Now we just need to send these tokens back within our response. So let's start with the refresh token. It's the hardest one. We have to send that back in a cookie. So to do that, I'll say res.cookie. That instantiates the cookie. And we have to provide a name. So I'll say refresh token in camel case. And then I'll do the actual string or the value of the cookie. That's going to be the refresh token. And now we get to pass in some options. This is where we pass in the HTTP only, the secure, the same site strict, all that stuff that's going to make our cookie as secure as possible to hackers. So I'm going to go ahead and specify the first option, which is HTTP only. I'll set that to true. And I'll say same site, and we're going to set that to strict. And I'll say the last thing is actually secure. Secure operates based on all it says is this can only be sent across an HTTP connection. So an encrypted connection is basically what that means. Now, if we run this right now, we try to send this cookie back, this isn't going to work because right now we're operating on localhost, which is an insecure connection. So secure cannot be true in this case. So instead, I'm going to use a ternary operator and say process.env.nodeenv equals production. If it does equal production, this is the JavaScript ternary operator, then set that to true, meaning secure is true. If it doesn't equal production, set that to false. All the ternary operator does is it basically just says, it checks this condition. If this evaluates to true, it'll evaluate the thing after the question mark. If it evaluates to false, it'll do the thing after the colon here. So this will be set to one of these 2 values, depending on whether or not the node env is set to production or development. Node env is just an indicator of whether or not we're in the production or development environment, basically. We only want this to be secure in the production environment, just because that's the most important one, and that'll be on a HTTPS connection, so we're good to go there. And just like that, we've actually set up our cookie, and now we're just going to return a response. We're going to say res.status. I'm going to say 201. That stands for session or something created. So in this case, a session has been created. And I'm going to give a payload of an object. The object's just going to have, we use destructuring to pass in the Axios token. I'm going to say success is true because it is indeed true. And just looking through this code, I think we're good to go here. So the last thing I'm going to do is I'm going to go to the terminal. I'm going to restart the server. just because environment variables need to be restarted. The server needs to be restarted in order to identify them. So take a second and that'll go. All right, so that's listening now. And what we're going to do is we're going to go over to our API.rest file, and we're going to send our first request to log in our user. I'm going to say post HTTP localhost 5000 and API/auth/session. I believe we've already set up the index file, right? Yeah, we have. All right, that's cool. So now that we're making a post, we need to specify some stuff within the body, like the username and password. So I'm going to say content type because the Express client needs to know what we're sending it in. I'm going to say application.json. Now we can specify the JSON data. So I'm going to say username, and we're going to say hack the south is our username, and the password. I have no clue what the password is. So we're going to check our database and check for the existing hack the south user. We're assuming that the user is already existing. They're just going to log in here. So I'm going to paste the password there. That should be all we need to send this request. So let's go ahead and send it. And boom, as you can see, we have 201 created, and we're getting back our access token, which looks like this. And we're getting back success equals true. All right, that's probably the most difficult part of this entire development part. So the next thing we're going to do is go over to the middleware file and write our very first middleware. So as you know, we're going to return the refresh token and access token. We've just done that. And now we need to make a request with the access token in the header, which the middleware is going to check for. So it's going to check the access token whenever we make a request to the resource API. I'm just going to go over to this, make one more request, just to confirm that, yeah, we do have the refresh token here. So that's obviously good to know. Right, cool. So let's go to the middleware file, and we're going to import Jwt. So I'll say const Jwt equals require JSON web token. And that's basically all that we need to import here. And now we're just going to write the middleware function. So we're going to say const Jwt middleware rec res and next. That's how a middleware function is generally formatted. And we're going to say module.exports Jwt middleware. And now I'm going to go ahead and write the middleware function. So in order to do that, what we're first going to do is check to make sure the access token exists in the header. What is a header and how does that work? So when you're sending a post request or even a get request to a card, so this middleware is basically going to act whenever we send a request to private data. Our cards router, our cards route here, basically gives access to private credit card information within our database. So whenever someone makes a request to the cards route, they're going to make a request to get some sort of specific credit cards data. That is basically the most private you can probably get, in my opinion. So in that case, whenever our middleware sees that request, it's going to intercept it and say, show me your access token. And if there's an access token, it'll let them in. If not, it'll say get lost. So we're going to say, I just need to separate these requests by saying 3 hashtags. That's the way of separating 2 requests. And I'll say get HTTP localhost 5000 API/cards. And we're going to specify user ID for the cards. That's how the cards route works. So a user ID in this case will be 458017 from what IntelliSense is telling me. So that exists within our database. So it's just going to get the specific cards that it corresponds to that specific user ID, which is that. I'm actually going to change the user ID. Or actually, no, that's fine. We'll leave it as it is. Forget about that. Never mind. And now we need to specify our authorization header. So I'm going to go ahead and say the header of authorization. That's where we store our specific access token whenever we're sending a request. And I'm going to say bearer. And I'll explain in a second why we say bearer. So bearer is just a way of, like, it's just the industry standard. Whenever you're sending a Jwt, you say bearer and then you put the token. I honestly have no clue why that is, but that's basically how that works. So we send a token, we put the access token here. And this is literally our way of telling the server that we're an authenticated person. This little one line is here is how we do it. So knowing this, knowing that our token is going to be here within the authorization header, let's write this specific function. So we'll say const access token equals rec.headers.authorization. And we're going to say dot split, because remember, that's going to be a string. We want to get only the access token. We don't really care about the bearer. I have no clue who invented the bearer part. There's probably a good reason, though. So that the splits, we're going to split based on the space delimiter. And what that does is splits it into 2 different arrays. Just one array. It's going to split it into something like this. It'll be bearer, and it'll say the specific token that we have is going to be the second one. And that's why we're going to get the second index of that specific authorization array that we have there. That's going to return us our token. Now, say the header doesn't exist. We obviously want to send back saying, get lost because you don't exist. So we'll say access token, and we'll return. We'll say res.send res.status, and we'll say 401, which means, actually, we're going to say 400. And that means bad request, meaning that you have some missing information. Your request is not formatted properly. So payload is going to be bad request, and the success is going to be false. So from this point onwards, we can assume that we have an actual access token. So now we need to confirm it, right? So we're going to go ahead and say jwt.verify. That's the specific function we use. And we pass in the token, pass in the access token. And now we got to pass in our secret or public key. So we'll pass in process.env the key that was made for this access token. So this is literally where we're going to verify the token. And this is how Jwt works without a database. It checks the access token by the original secret that we used to create that token, if that makes sense. So we're going to pass in that secret that we originally created. And then we're going to go ahead and it allows us to give some options. So we're going to have a callback. We're going to say error decoded. It can be an error function. And that's how that works. So basically, this is going to get the access token that we literally created within this API request. So let me send that again. So we get the specific access token here, right? Now this access token was created with this specific secret because we passed that in when we created it. So this middleware file is going to go ahead and it's going to say, okay, now that I have this access token, let me crack it open using the original secret that I created it with. And this is how Jwt operates without a database to answer someone's question from before. So when we're verifying it, what we're going to do is we're going to say if error, and error just means that there's some sort of problem. There's either it's expired, it's invalid, some issue is there when we're trying to verify the access token. So if there's an error, throw the error. And if there's no error, then we're going to assume that the access token is valid. We're going to say request.userid equals decoded.userid. I'll explain that in a second. And request.username equals decoded.username. So when we crack open this, when we verify this Jwt, we get the decoded value, the payload within the Jwt in the form of the decoded variable. So I'm just setting the request user ID into the payload values, just in case we might need to use that in the future. That's an example about how you would use the payload within the Jwt token. So at this point, if there's no error whatsoever, we can forward this to the actual request that it's going to by using the next function. Now, if there is an error, we don't want our application to crash. So we're going to use the try catch block to catch that error and then tell the person who sent this request to go somewhere else because they're not authenticated. So catch, and we're going to say res.status, and we'll say status 401, and we'll say payload is invalid access token, and success is false. And that right there is our middleware function. We're going to go over to index.js, and we're going to import that middleware. So we're going to say const jwt middleware, acquire that middleware. It's technically not a router, but I just put it there because I feel like it makes sense. So where we position this middleware is actually very important. So if we position this middleware above the cards router here, if we say app.use jwt middleware, what that's going to do is it's going to apply for all these routes. Now, think about it for a second, right? If the middleware applies for the authentication route, meaning we need an access token in order to reach that route, how do we originally create an access token, right? If we don't have an access token, but we need an access token in order to create one, that doesn't really make sense. Because of that, we're going to take this middleware and put it over here and move this authentication router at the top. The reason for that is because we don't need authentication in order to secure the auth router routes. They're just going to do it themselves. They don't need the middleware to do that. It's just that the cards router, which is private data, needs to do that. So the middleware is now going to apply for everything beyond this specific cards route. It's also going to apply for this health route, which we don't want. So I'm going to move that upwards. All right, that's basically it in terms of the middleware. And if we now try to make a request with our card, so we're just going to have just the token here, we should see something that says invalid access token. And there you go. It says invalid access token because we obviously don't have a token here. Now, if we go ahead and create an actual access token, it's going to expire in 15 minutes, which is fine. And we send that request, we are able to get the user information. If we even tamper with it just a little bit and send it again, invalid access token is what we get. Now, one thing I did tell you is that the Axios token expires. And I actually want to show you guys like firsthand how that works. So I'm going to head over to auth.js. I'm going to change the Axios token expires in to only 10,000 milliseconds, which is 10 seconds. So server should refresh because we're running on NodeMon. And when it does, we're going to send this request here, create a new Axios token. And we have to be very quick here because it's going to expire in like 2 seconds. So I'm going to paste that. And if I send that request, I'm getting my initial data. But if I send it again, it says invalid Axios token because it's now expired. And that's how quickly an Axios token can expire if you set it to 10 seconds. This is what our request is going to look like when we send an Axios token that has now expired. So logically, now that we've set up our entire process, we're able to get the user information. It's time to refresh our Axios token and set up the refresh route, make use of this refresh token within the cookie. So I'm going to head over to the refresh file, and we're going to finish up the refresh route. So I'm going to say router.put. So the put request is basically just stands for update a specific session. So we're going to say put session, and that updates the session essentially. And write out some boilerplate here. And I'm going to go and I'm going to do the exact same thing as I kind of did for the middleware. I'm going to make sure that the refresh token exists in the cookie. If it doesn't, send them back and say, you're not allowed. And if it does exist, verify it. And if it is verified, send back a new Axios token. So let's start by saying const refresh token equals request.cookies.refresh token. And that's how we get the refresh token from the cookies. And we're going to say if the refresh token does not exist, remember there's no bearer in the cookie, so we don't need to do any of that split stuff. Then we'll return res.status. And we'll say 400, because again, it's a bad request. And we'll say success is false because it is obviously false. So now we actually have a refresh token. We just need to verify it. I'm going to go to the middleware file, and I'm going to copy this code because, well, I'm too lazy to type it out. So I'm going to paste it here, and I'm going to say verify the refresh token. We're going to pass in the refresh token secret that we used to originally create it, just like for the Axios token. And if there's an error, we're going to throw that error. And if not, we don't want to go to the next request. This is not a middleware function. We want to create a new Axios token. So I'm going to take that specific line that we used to create the Axios token before. I'm going to use it again. And the only thing that's missing is this token payload, because that's like actually unique to this specific route here. So we're going to create a new token payload by saying const token payload equals user ID, and we'll say decoded.user ID, because again, just like the middleware, we're going to decode and get the payload from the decoder JWT. And I'm going to say username is decoded.username. And that's it for the token payload. And we're creating a new Axios token. It's going to expire in that sense. Now what we want to do is just return that Axios token. So we'll say res.status, say 200, and we'll send payload. We'll say another object again. We'll say Axios token, and success should be true. The reason we're saying 200 instead of 201 is because 201 stands for something new has been created. 200 just stands for updated or OK, so we'll just say 200. And lastly, just like the middleware request, we need to cache the error in case an error comes up. So I'm going to go ahead and cache that error. I'll say res.status 401.send. Payload will be invalid refresh token, because this means if we get an error, that means that it's invalid or it's expired. And we'll say success is false. And we've just created our refresh route. The last thing that we're going to do before we wrap this up is we're going to go ahead and we're going to write our delete route. So I'm going to say router.delete, and this is our logout route, right? So you might have already guessed, in order to log out the user, all we need to do is take out the refresh token. That way they can never request more Axios tokens. And you'll see in a couple slides how we actually use the refresh token in the client to check whether or not it's they're logged in. All you have to do is just check on the client to make sure that the refresh token exists. If it does exist, then push them into the actual application. If it doesn't exist, then make them log in again. So logout, all it's going to do is it's going to check for the refresh token. If it doesn't exist, just like before, we're going to return and we're going to say bad request. If it does exist, then we're going to say res.clearCookie. That's how we clear a cookie with Express. Specify the cookie name, and we'll say res.send status I'm going to send a status of 200 saying you're all good to go, you're deleted. So this right here is basically our entire authentication system. It might seem like a lot of code, but honestly, it's a lot of code just repeated over and over again. If you can take this authentication system and build a project with it, even within Hack the North, it's a very easy plug-and-play system because you don't actually even have to worry about anything from now on, right? The middleware is going to take care of your authentication, and all I have to do is do stuff from the client. From the server, there's no more stuff required on your side. So we're going to test everything out here. And the next request I'm going to write is I'm going to say put localhost and it's API/auth/session. We don't even need to pass anything there. And the last thing is going to be delete, which is going to be the login, the logout. So let's say API/auth/session once again. And let's test out the entire cycle. So I'm going to take out this refresh token here. And let's kind of mimic a user flow here, right? So user's going to go in, they're going to be on our login page of the application on the client side. They're going to enter their username and password, and the client side is going to make a request to the post/session. So that is going to log in our user. We'll send that request, and we get the access token. So the user is going to go ahead, take this access token. The client's going to take that access token and send it to the server and say, give me some data. You're just going to make some stuff. It'll do some changes, all while the access token is being sent, and it's going to go ahead and expire. What's the client going to do? Well, they'll go ahead and make a new access token. We'll copy that just to make sure that it's working. We'll paste it, and we'll send that request, and we get that data. It's going to expire again because we have a short expiry period of 10 seconds. And now the user is kind of tired. They're bored of it. They're going to log into the application. So the client's going to send the logout notification, and we get a 200 OK back. How do we test about whether or not our refresh token is still in the cookie? Well, we can just send a refresh request, and it'll send us a bad request notification because the refresh token shouldn't be in the cookie anymore now that we've deleted the refresh token. So we're basically logged out of the application. So we'll send this, and it says bad request, and thus we have been logged out of the application. That right there is an entire user flow, and we just built an entire authentication system from scratch. So yeah, great stuff, guys. That is all we're doing for the coding section, and we're going to continue on with our slides. And we're going to talk a little bit about Jwt and the client. I'm going to get to all the questions at the end just because we only have like a couple minutes left. I'm just going to finish up these slides. So let's talk a little bit about Jwt and the client, right? So how the Jwt and the client works is that we have a client application here. It's going to initialize a request once the we're assuming the user's logged in already. So it's going to initialize a request. And if you're using Axios, which is a popular request library on the front end, then there's something called an Axios Interceptor. Probably exists for other things like Axios as well. So all an interceptor does, it's kind of like a middleware in the server, but for the client. It intercepts a request and it says, okay, I'm going to run a specific function once I intercept you. So what we want it to run is we want it to say, is the access token expired? If the access token is expired, then go to the auth router and get a new access token. If it's valid, just continue. So if it's expired, it'll get a new one, and then it'll continue on, and it's going to check if it's valid. If it is valid, which it will be, it'll go to the resource router, it'll make a request, and the resource router is going to return data to the client. That's going to keep going and going and going until the access token is expired. And automatically, we don't even have to do anything from our side. The interceptor is going to take care of it. It'll go ahead and say, oh, now the access token is expired. The user wants to do something in the application, and it'll make another request to the auth router and return the access token. This will continue going until the user logs out of the application. So this is a great way to implement Jwt in the client, because obviously we didn't have time to talk about that today due to the length of the workshop. And lastly, we're getting to our last section here, which is the future of authentication. And I've been talking about Jwt a lot during this entire PowerPoint. I do want to mention that it is a secure system, but in my opinion, and in the general software industry, there are better technologies that are going to fare better into the future. And the reason is because the future of authentication is passwordless. Jwt does require tokens and things like that, but ultimately it requires the user to send in a username and to send in a password. I'm not saying take away Jwt. I'm saying use Jwt along a passwordless solution. And the reason why passwords are so obsolete is because, one, people end up using passwords for too many sites, right? A lot of people do that. Even software engineers, I guarantee you, probably do that as well. And the issue is that with technologies like quantum computing coming out, quantum computer is literally just a much more powerful computer than your average computer, and it can run brute force attacks on Google or Facebook or other big authentication systems. It can run brute force attacks where you have a very, very complex password, and it'll run through all the possible combinations of a password much faster than our average computer. The reason why we say have a long password, have ones with special characters, a capital letter, is because that increases the amount of combinations that is possible for a password to be made. That exists for computers, because that just means that the computer is going to take like forever to guess all the combinations and then try to test all those combinations to break into an account. Quantum computer can probably do that in like a fraction of a regular computer's time. So because of that, it's quite like clear that passwords are going to become very obsolete. And even if they don't, honestly, they're just not as secure as things like email verifications, social logins, biometrics is one of them. Blockchain, that's one of them. I'm gonna skip that though. And we have SMS and two-factor authentication. These are all really safe technologies, and the reason for that is because they rely on the user having access to another account, whether that's their Google login, which is difficult to get into big companies like Google, Apple, Facebook, and GitHub. It's not impenetrable, of course, but they're probably a lot more secure than your everyday application and just you doing authentication yourself. Email is another big one. No hacker's gonna hack into an email and get that secure login link. Same with two-factor authentication. No hacker's gonna go and get into your like two-factor authentication application you have on your phone or like SMS. They're not gonna do that as well. So these prevent the use of passwords and make it much harder for hackers to get access to a password the user uses. Instead, the user requires some sort of other device or service in order to authenticate, making it 10 times safer. And the last thing I'm going to talk about before we end this off is the next steps. So there's 3 next steps that I would suggest. The first thing is called hashing and salting. We actually made a major mistake within the world of cybersecurity here. We stored our password in a database without any type of protection. That is a big no-no, because although like big databases like AWS and GCP, all these big cloud platforms, they have databases that are secure, but they're not impenetrable. There are indications, there are like certain circumstances where AWS and like GCP, Google Cloud Platform, they have like certain scenarios where people actually do hack into them. And when someone hacks into your specific user data, the users aren't going to be mad at Google, they're going to be mad at you, right? So ultimately, hashing and salting is the way of basically encrypting something. It is completely different from encrypting. Fun fact, hashing is much stronger than encrypting. If you see encrypting, just know that hashing is stronger than it. Encrypting is a big marketing buzzword that's used in the industry a lot, but hashing is a stronger method of encryption. It basically transforms that password into kind of like an encrypted form, if you will, and that makes it so that if a hacker gets it, it's hard for them to break down that specific token, kind of like our Jwt, back into its original form. So that's what hashing and salting is all about. I've linked the article here. I've also linked it within the GitHub repository as well. So all the articles is there as well. Then there's another guide to implementing two-factor authentication, and why two-factor authentication is important is kind of this article. I really recommend a service called Magic Link. That's where I got this specific image. It's a very, very easy to use like developer SDK that makes it easy to integrate social logins, two-factor authentication, all the stuff that you see here, Magic Link provides. So they're a really cool startup. And the last thing is Jwt on the client side. That's something we didn't cover in this workshop, but it's very, very important. The next step to securing cookies is something called a Csrf token. There's this really cool article by a guy called Ryan Chenke, and he has like a sick article on how to implement Jwt on the client side. I learned a lot from that article specifically. So if you're a React developer or any other developer in general, make sure to check that article out. It talks a lot about protecting cookies and just Jwt on the client side in general. And that brings us to the end of this workshop. Thank you guys for coming to it. I really hope you guys learned something. And yeah, this is the point where I'll take any questions and check out the Slido. All right, we have like 10, 15 minutes left. So I feel like my screen is frozen. All right, I'm just gonna, all right, so let's start at the very bottom. So aren't passwords pretty hard to decode? Oh, hold on. Aren't passwords pretty hard to decode even with a client computer because of the vast size of possible combinations of keys? Exactly, yeah. Passwords are hard to decode. The quantum computer part I'll talk about in a second, but basically this question is saying, like, you have so many combinations of passwords, isn't it very, very difficult to decode them even with like a quantum computer? They're very hard to decode with a normal computer just because there's like I forget what the specific statistic was, but it might have been like 200 years or something is how long it would take your average computer to decode password. Even the strongest computers, it would take that long to decode or essentially go through all combinations of a password in order to get or try a brute force attack on a specific service. So yeah, they're very difficult to code to decode for your average computer. Quantum computers are a lot different because they don't work in the same way as the normal computer. They don't work by having 2 bits, 0 and 1. They have what's called a qubit. And I'm not going to explain much about quantum computers here, but I just know that they're much more faster than your average computers. And even if we take away the fact that it's difficult to decode them, we use them for so many different services, right? We use them for like, we repeat them so often. I think this is like a statistic or something like 30% of all of our services, all of our passwords are repeated. And that's so insecure, which is why passwordless technologies are probably going to become very, very massive in the coming future. So I hope that answers that. Can you share this project? Yeah, of course. What I'll do is I'll actually upload the code that we just wrote to our GitHub repository. I'll upload this within like 10 minutes of ending this workshop. So you guys can check that repository. It'll probably always be up and you can use it for whatever projects you guys want. Should we use the same secret for all Jwt tokens? If someone cracks a secret, they can decode all the tokens. How would you manage the secret token map? Okay, so what this question says is, should you be using all the same secret for every single token, and is that safe? So use a different secret for every single type of token, which makes it more difficult to crack, obviously. The reason why I'm not too worried about someone cracking the secret is because people actually won't be worried about cracking the secret. It's actually relatively difficult to crack the secret that was made with the token, just because hashing is very, very difficult to, hashing is a very, very strong way the Jwt uses to, I guess, take that specific secret that we have and transform it into a token. So hashing is difficult to break. It's used by like government officials, used by government agencies in the US. So they're very, very strong, especially the best ones. So I wouldn't be too worried about cracking that token. Much more importantly, I'd be worried about if someone getting access to the token. If someone gets access to your access or refresh tokens, then that's obviously something that's very, very difficult. Can you link the repository in chat? I think I'll just ask Leon, which is our organizer here. So I think you can probably do that. So yeah, hope that answers this specific question. What is NPM? I'm gonna assume that's like a joke. That's Node Package Manager is what NPM stands for. If you're being serious, it's just like a package manager for Node.js. Isn't it possible to remove the session from the auth router and instead provide it as a middleware argument and use the auth router variable? I'm trying to wrap my head around what this means. So remove the session from the auth router and instead provide it as a middleware argument, use the auth router variable. I'm not too sure exactly what you're talking about here. So feel free to just DM me on Discord if you have another question related to that, and I'll get to it as soon as possible. What is my name? My name is Harshit. I specified this at the start of the workshop. Is there a benefit from making your own Jwt system compared to using an existing system out there? This is a great question. So Eric is basically asking, should we use additional services that are out there? Like there's platforms called Auth0, Firebase Auth, there's things like that out there. Should you be using that service compared to Jwt? Honestly, I'll provide my opinions, okay? So the advantages of using Jwt and using your own service is that you know how it works, right? So that's the first thing. A lot of people kind of assume that big companies and big services are very, very secure and you can really trust them. I wouldn't encourage this that way of thinking, just because they can be broken down. Like it is possible to break into a big company's database. It has been done in the past, and it's possible that they have a bug there. Like even Fastly, not sure how many of you guys have heard, but like there's this service called Fastly, which services like Netflix, Amazon, all these big companies, and that just broke down like a couple months ago. So it's definitely possible for big companies to make mistakes. So the big advantage with making your own system is that you know how it works and you know that there's no bugs within there. That being said, bigger companies do have more sophisticated auth systems. So it depends on the app is my answer. If you have an application that's very, very secure, you have a lot of users, there's a big demand for security, maybe consider going with the Auth0 service. That being said, it does cost money, of course, so you have to keep that in mind. It's also a lot easier to integrate social logins, passwordless technology there as well, is what I would say. So that's one benefit there. Personally, I think it's good to understand how Jwt works so that even if you're using Auth0, you're still going to be able to have that background knowledge there. So my answer is like, it's really just dependent on the project. I know that's not an entire answer, but if you want, just DM me and I'll probably, we can talk more there. And I think that I answered all of these other things. Can you link the repository? How will the token? Okay. Yeah, we're going to link the repository in chat. Is it possible to get this project to review later in our own time? Yep, I'll update the GitHub code, and this repository is always going to be up, probably like forever. So I'll keep it up there. How will the token be updated? Not sure exactly what that means. I'm assuming it's going to mean how is the access token going to be refreshed? Well, you're essentially going to be sending a refresh route, a refresh request with the refresh token, and that'll refresh the access token. That's how the access token gets updated. Hope that answers that. I think there's an environment variable error on mine. Yeah, just feel free to DM me for specific requests like that, and I'll probably help you out in Discord, probably easier than helping you out here. Yeah, I think we've basically gone through most of the questions here. I think that's basically it. We're kind of reaching the time limit here. If you guys have any other questions, feel free to, where is my contact info? All right, whatever. Feel free to just DM me on Discord. This is my tag, or just email me as well. My email is in the hack pack, and I'll get back to you with all the information for your question. And yeah, that's basically it for this workshop. Thank you guys for coming. Hope you guys learned something, and good luck for the rest of the hackathon.